Hi everyone. So this is Algebra 2. This is lesson 4.2. Today we're going to talk about functions and relations. And so kind of two big things, right? Our goal is to be able to tell the difference between a function and a relation. Uh, so uh, so how do we do that? And then so that's kind of just understanding the vocabulary of it. And then the second part is how to describe the domain and range of a function. And so when we talk about the domain and range of a function, we'll be talking about sets of points or sets of numbers. And so we'll use that set notation that we used yesterday, either an inequality or in most cases we're going to be using interval notation. So here's some definitions for you. I apologize here, the little watermark they put on the thing there kind of gets in the way. But so we have some definitions here. So we're talking about sets of points and sets of numbers. So when we talk about a set of points, we talk about a relation, right? A relation is just a set of points. It could be a set of individual points, 5 points or something like that, or it could be an infinite set, like all the points that lie on this graph, or all the points between -5 and positive 20 or something like that. Right? So we're just looking at a group of points. When we talk about the domain of a relation is all the x values. So it's a collection of all the x values of a relation. When we write those out in as individual numbers, we write them from smallest number to biggest number. And if there's any repeating values, we skip those. So we just say that the individual numbers that are in there. Sometimes we'll write these as individual numbers. Sometimes we'll write them as sets of numbers. And so we'll be using interval notation or inequalities or something like that to talk about them. The range is similar. Range is the set of y values in a relation. So we have these a relation is a set of points, and then the domain is all of the x values, and the range is all of the y values. Okay. And then we have a special kind of relation, right? We call that a function. And a function is a relation where every member of the domain matches with only one member of the range. And the key part of that is only one, right? It's only one member of the range. So the domain matches with only one member of the range. That's the critical part, and that's what we're going to be looking for. There are some different ways of representing relations and functions. The first way is using set notation. So we've looked at these yesterday. This is the curly brackets mean a set. So this is the set of these 3 points. This is a fixed, set of points, right? There's only 3 members in that. We'd call that a discrete relation or discrete function. There's a finite number of points that are in there. So there's different ways of representing that. So here's the set notation. So here's the 3 points. The domain of this would be 1, 3, and 5. The x values 1, 3, and 5. And the range would be the y values, so 2, 4, and 5. And notice that I listed them in order, right? 2, 4, and 5. So we're just talking about those numbers themselves, not about how they relate to the other ones. So the domain is just those numbers. Here's another way we do it. We can describe these as it's what's called a mapping. And this side we list the domain numbers, right? So these are all the x values, 1, 3, and 5 listed in order. And then this side represents the range, so 2, 4, and 5. And then we use these arrows to describe how these numbers are related to each other. So 1 is related to 5, 5 is associated with 2, and 3 is associated with 4. So that tells us that relation. Notice it's a directional thing, right? It's a relation between the domain and the range. So we go from the domain to the range, okay? Another way we have of doing that is graphically. So we can draw a picture of what it looks like. So here are those 3 points shown on a graph. So that's another way of representing relation. And then the last way that we have is with the table of values. And so any of these representations work, and you'll kind of see them used interchangeably. Either set notation or a graph or a table of values are typical for what we see. You'll see these mappings kind of show up every now and again, but you know, it's kind of involved to draw these pictures out. It's way easier to, you know, write a table of values or just simply type out this set of numbers. So here's our first sort of test here. Right? We want to see if this is a function. All right. So there's a number of ways we can do it, but we want to go back to that definition. We talk about a function as being a set of points, right? A relation where every member of the domain only goes to one member of the range. So if I look at my domain, I have 3, 4, 3, and 5. Notice that the 3 in the domain repeats. Okay, that's not necessarily an issue, but it raises kind of a red flag. If I look at the range values, I have 1, 2, 5, and 6. But if I look at how they're related, 3 is related to 2, but 3 is also related to 1. So right here I've got a member of the domain, 3, right, that goes to two different versions, right, two different numbers in the range. So 3 goes to 2, and 3 also goes to 1. So is this a function? We would say no, this is not a function. Okay. If we were going to list the domain of this, we would say the domain is, so we're using sets here. So our domain is going to be 3, 4, 5. 3, 4, 5. And our range is going to be 1, 2, 5, and 6. 1, 2, 5, and 6. Whoops. Okay. When I look at the domain and range like this gives me a clue that this is probably not a function because I have fewer members of the domain and more members of the range. That means that the domain, some part of the domain is using multiple parts of the range. And that's our big definition there, right? That's what determines whether it's a function or not. So we look at this one. Is this a function? So similar set of points here. So if we look at our domain, we have 3, 4, 5, and 3 again. So we have that 3 repeated in the domain, but this time in the range, 3 only goes to 1. It does it twice, but 3 is only associated with 1. So 3 only goes to one number in the range. So this is okay. This is a function. Okay, so this would be a function. And if we were to list the domain and range here, our domain would be 3, 4, 5 again. And our range would be, this time we have the smallest is -2, 1, and 2. So -2, 1, and 2. Okay. Again, I can kind of see from the domain and range here, I've got the same number of domain in the same number of range, and so that tells me that it's probably a function. You know, I don't know what the relationship, just looking at the domain and range, I don't know what the relationship is, but it gives me a clue that, you know, they're matched up evenly there. So pretty good chance that that's a function. So here's another one. Is this a function? So again, we're going to look at these sets of points. If we were to write this out as a set of points, we'd have the point 4, 12, 5, 18, 7, 12, and 8, 19. And so we're trying to determine if that's a function or not. So the thing that confuses a lot of people is here we have 12 being used twice. Okay, we have 12 being used twice right here. But if I think about what that says, it says that I have the point 4, 12 is one of my points, and the point 7, 12 is another one of my points. Now, I think about my definition of a function, I'm looking at the domain numbers. So my domain numbers, 4 only matches up with 12. 4 doesn't match up with 12 and 18 and 19 or anything like that. 4 only goes to 12. And the same thing with 7. 7 only goes to one number. 7 doesn't go to 12 and 18 or 19 or anything like that. 7 only goes to 12. The fact that they both go to 12 we don't care about. We just care that 7 in the domain only goes to one number, and 4 in the domain only goes to one number. Okay, so is this a function? Yes. Okay, and our domain would be here 4, 5, 7, and 8, and our range would be 12, 18, 19. So in this example, similar sort of thing, we've got some members of the domain here, and we have the members of the range here. And so if we look at this, the thing that really alerts us here is we look at number 4 in the domain, and we see 2 arrows coming off of it, and those 2 arrows are going to 2 different numbers. So 4 goes to 1, but 4 in the domain also goes to 7. So that is textbook definition, right? That is not a function. 4 is going to 2 different numbers. Number in the domain is going to 2 numbers in the range. That a function? No. Okay. And again, our domain is 1, 2, 4, and our range would 1, 2, 7, and 8. Now, this time we don't know the points. In fact, we don't even know the numbers, right? We don't even have any values for any of those. So graphically, right, can we tell if this is a function even if we don't know what the points are? Well, what we can do is we can kind of look at the x values, right? So our domain or the x values. So our domain is going to go along the x-axis here. So the numbers in our domain, so here we have an x value, 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 and here, we look here, we have an x value, but look, there's one y value here, and there's another y value here. So this x value, whatever that is, right, is going to 2 different y values. Right? It's going to 2 different y values. So the way that we can tell that is because they're lined up vertically. And that brings us to kind of our first, well, not our first, but our second kind of test, right? We can use a vertical line, and they actually call this the vertical line test. So if I have a vertical line, right, and I kind of sweep that vertical line along the x-axis, if that vertical line touches more than one point at the same time, I know it is not a function. So if I look right here, yes, that is not a function, right? I see that for this x value, I have 2 different y values. So that is not a function. Now, if we were to be asked about the domain and range, we don't have any idea. We don't know the values of these points, and so we can't list out the domain and range, but we can tell that this is not a function. Okay, and so we call this the vertical line test. Here's another one. Again, we kind of use that vertical line test. Notice that this is not just a discrete set of points, right? It's not a fixed set of points. It's actually all the points, right, that make up this graph. So there's an infinite number of points here, even though there's not arrows on the end, and I don't know what happens if it keeps going or if it stops. But I do know that there's an infinite number of points along here. So this is what's called a continuous function, right? All those points are kind of connected, and there's no real gap in between them. The other function, we would call that a discrete function or discrete relation. But I can use the vertical line test on this. So I kind of move this through here, and you know, like maybe right there, like there could potentially be 2 points lined up, but I don't really think so. Based on just the graph that I have here, you know, in the state that it's in, I would say that yes, this is a function. Okay, and the reason is because it passes the vertical line test. I still don't know what the x and y values are. I don't know like an equation to describe this. I don't know anything about this other than the graph, but I can tell from the graph, because it passes that vertical line test, this represents a function. So this one's a little more tricky. We look at this example here, we get our vertical line, and we start looking at this. This time we do have some numbers. Okay, so we have some indication of where these are in space. We also know about the end conditions. I can see I've got a solid dot on either end, which means it includes those points. Whoops. And so if I look at this line and I move this line along here, it looks like it does okay until we get right to about here. And here it's a little unclear. It'd be nice if I could zoom in on that and see what's going on right there in detail. I don't have an equation for this. I can't just put it into a calculator and kind of see what it would look like and zoom into it. But I think that is a continuous curve there, that it doesn't actually go vertical, that it comes to a point right there and keeps going. So I think this one, I would say this is, yes, a function. Okay. Now, that would be just based on the information that I have. It could be that it's not a function, and I would have to, know more information to figure that out. But from what I can tell, just from the graph, I think that that's a function. Now, here when we talk about the domain and range, it doesn't make sense for me to just list out a bunch of numbers, because there's an infinite number of points in between here, right? There's an infinite number of points on this segment. So no way to just list them out. So what we're going to do is we can talk about them as a set. So we're talking about the set of all the points, and we're going to describe that set of points. So for this, I would look at the domain. So the domain of the x values. So if I go from smallest to biggest, the smallest value that x can be is -8. So I'm going to put -8. And then if I go to the right, the biggest that x can be is +8. So x can be from -8 to +8. And I've got those solid dots on there. So those solid dots means that -8 and +8 are part of that set. So I'm going to use square brackets on those. So I'll put some square brackets on that. So I would say my domain is the interval between -8 and +8. And we would say that that's inclusive, or that includes -8 and +8. Now, if I look at the range, right? When I'm talking about the range, I'm talking about the y value. So I'm looking at this direction, right? I'm looking at the values along this axis. And so I can't just look at the ends, right? I have to look at the bottom of this graph, right? The bottom of this graph, which is right here, and the top of this graph right here. My range is vertical. My range is going from smallest to biggest. So when I look at these values, it looks like, let me move this line out of the way. You can see those numbers a little bit better. There we go. So -4, right, is my smallest number. So if I go over here, my smallest number is -4. And then if I look up at the top here, my biggest number is +4. Okay, so the bottom of that graph is at -4, and the top of that graph, the y value, is +4. So that's going to be my range. It looks like it passes through those points, right? -4, 4, and -4. Sorry, 4, -4, and -4, 4. So it looks like it passes through those points. So I'm going to say it includes those. So I'll use square brackets on those. Okay, so this is where our interval notation is going to come in handy when we're describing these large numbers, this infinite number of points in between here. Okay, and then the last thing I want to kind of touch on here is just what's called function notation. And so there's a lot that can be said about this, but the simple version is, like, we just have multiple ways of representing graphs and functions. So typically, in the past we've used this equation notation. So we build an x and a y table, right? Our x is our input and our y is our output, and we plot those as x and y. But there's some limitations to that, and it can get confusing when I'm talking about like two different equations that are both written as y equals and y equals. What I'd like to be able to do is to assign names to those, and so what we do is we use function notation. And so function notation allows us to assign a name to that function. So we say this function here is called f. So this function, the name of this function is f, and we say this is a function of x. So f is a function of x. It means my x is my input, and my f of x is my output. Now I can name my functions whatever I want. I can use whatever letter I want or combination of letters that I want. It's really typical to have a function called f and another function called g and another function called h and another function called k and l and p and so forth. You can name your functions anything you want, just like you can name your variables anything you want. But we use this function notation. A lot of people get confused here. They think that this means f times x, and that's not what it means. It means that this is a function and that x is my input to that function. Okay, so in this case, it says to evaluate this function, I'm going to take the value x, I'm going to divide it by 2, take the opposite of that, and add 6 to it. Right? And that tells me how to get the output for that function. So in this case, if 3 is my input, then my output is going to be negative 3 over 2 plus 6. And if I work through that, this is a fraction. I'm going to turn this into a fraction. This would be 12 halves minus 3 halves. That's going to give me f of 3. Right? F of 3 is equal to 9 halves. And so that's how I would say that. I would say f of 3 is 9 halves. So if I take 3 and I plug it into this function f, I get 9 halves out as an answer. Now, please don't try to divide this by 3 and solve for f. That's not what this means. It simply means this is a function, and the input is 3, the output is 9 halves. Okay, you'll see these used interchangeably, and it's very common to kind of switch back and forth between those. The function notation is a little more formal, and we're going to be using that more and more as we move forward. Okay, and then the last thing I wanted to talk about was how to graph some of these. So let's say that I have let's say I have a function of x, and that function says to take the value of x, add 6 to it, and then take the square root of all that stuff. Okay, so whatever my input is, I'm going to add 6 to it and then take the square root of all that. I might have a question that says, well, what's the domain of that? Well, I don't really know. At this point, I don't really know. If I'm familiar with what these kind of graphs look like, I might have an idea, and we're going to, kind of move down that road to understanding these functions and what they mean, and how we can get information like that out. But for right now, I don't have any idea what this looks like. So what I'm going to do is I'm going to use my calculator to do that, to figure that out. So I'm going to show you 2 ways to do this. The first way is with a TI calculator. And so let me switch my screen up here. Okay, so I got my calculator here, my TI calculator. So I'm going to go ahead and turn that on, clear that out. What I want to do is I want to make a graph of this. I want to see what this looks like. So I'm going to put this function into my calculator. Now, people at TI probably don't want me to say this. All the textbooks are written around TIs and using them, but in my opinion, the TI calculators are old technology. The newer ones are kind of nice, but it's still an old technology. They actually don't use function notation in the TI-83s, and some of the newer ones they do, but in these older ones they don't. They actually use equations. So in order to put an equation, I have to go to this y equals right here to put this equation in. So I go y equals, I've got one in there already. I'm just going to hit clear to clear that out. So this is y equals, and they say y1, y2. These are just different equations, right? So if we were using function notation, this might be f of x, this might be g of x, this might be h of x and k of x and so forth. But so these just represent different functions or different y values. So I'm just going to put this function in here. It's the square root of x plus 6. So to get the square root, I'm going to put second square root. And then I'm going to put, you notice it gives me an open parentheses there. I'm going to use x. X is right here. Plus 6. and I'm going to put a close bracket on that. So that says take x plus 6 and then take the square root of that. Okay. If I want to see what that looks like, I can just graph it. My graph right now is not showing me the whole thing. It's not showing me the information I want to do. So I'm going to zoom and change how this is displayed. So I'm going to go to zoom, and then I'm going to come down here and I'm going to choose number 6, which is standard. So zoom 6, and that switches to just kind of the default view, and that works for a lot of things. But in this case, it shows me what the shape of this graph looks like. I don't think it's a straight line. It looks like it's curved a little bit. It's kind of hard to tell from here, but it looks kind of curved. It also looks like it has a definite endpoint right here on the left-hand side. On the right-hand side, it looks like it continues on. Okay. Now, I don't know where that point is. I can zoom in on that, and I can do some other looking around to see. But an easy way to tell is to examine the table of values. Okay, so I can build a table of values of this, and the way that I do that, right above my graph, I have this table. So to access the table of values here, I'm just going to go second table, and it's going to give me a table of values. Okay, and this table of values is dynamic; it'll change. And if I scroll through those, I can see that at -6, my y value is 0, but to the left of -6, I get an error. Okay, and I'm going to let you guys try and figure out, like, what does that mean, right? Why would it give me an error right there? Okay, but what I can see is that -6, 0, like that looks like the bottom or the left side of my graph. All right, so if I were to talk about the domain, this value here gives me my left end. Okay, and then I can scroll down through this list and I can see, well, it just keeps increasing and increasing and increasing, and so it doesn't really seem to end. And so I think that this graph goes, on the left-hand side, it goes from -6 to positive infinity. So in my assignment here, I'm going to say the domain here in interval notation is -6 to positive infinity, right? The infinity always gets a round bracket. It can be equal to -6. -6 gives me a value of 0, so that's a valid value, and so we're going to include a square bracket on that. Now I want to show you one other way to do this, and that is with Desmos. And so I'm going to bring up my browser here, and I'm going to switch over to Desmos. Desmos is a great, very user-friendly interface to this. Desmos doesn't care if it's function notation or y equals notation. It'll accept either one. So if I wanted to put this function in, I could say, f of x is equal to, and then I had square root. And so down on the bottom here, there's a little math keyboard that I can use to type math. I can also type in, just like I would in my OpenMath, SQRT and that sort of stuff. But I'm going to use the square root symbol. And then inside that, I want x plus 6. And I typed this wrong. This should be f of x. So that's why it's giving me some problems there. So there's f of x, okay, is equal to that. So there's my graph. And I can see here, it shows me some points on there. There's that point right there. I can see it crosses the y-axis right about there. It curves on. I can use my mouse to zoom and scroll, and I can see that it keeps going forever and ever. Okay. Now, if I wanted to look at a table of values of this, I can do that in Desmos as well. And the way that I do that is I go to this little gear right here, and I take this function and I convert it to a table. So I convert that to a table. And so here it gives me the function, and here's the table of values that goes with it. This is not dynamic. I can't just kind of scroll through that list like I do on the calculator, but I can just type a value in there. So if I wanted to see, like at -8, it tells me that that's undefined. At -7, I can also see that it's undefined. At -6, I can see that it's 0. Okay, and it tells me that on the graph as well. I can see that that ends right there at -6. Okay, so there's two ways of doing that. The answer is the same either way, but just two different ways of using that technology. Okay. If this function asked me to evaluate, if they said what would be f of -2, right? If I wanted to know what f of -2 was, well, I could just type it in here. But I could also just look it up on the graph. I could come over here to -2, and I could come up here and I say, well, it looks like that's the y value there is +2. So I would say f of -2 is +2. So I can look that up on the graph, or I can double check it in here. I can just say type in -2, and it would tell me that my f of x is +2. All right. Desmos is a really nice graphing calculator. I can't say enough nice things about it. They're good people. So I would get used to using Desmos. Get used to using the TI as well. Like, it's nice to be able to use whatever technology is available to you. But if you have a preference, if you have a choice, my choice would be to use the Desmos calculator. All right, we're going to go ahead and end the lesson there and take a look at the homework on 4.2 functions, and let me know if you have any questions.